we've got two kinds here. We've got something called ArcMap, which is part of the ArcGIS family of products. The folks that Esther and I work for make that software. And we also have something called ArcGIS Explorer. Who's familiar with Google Earth? Okay, it's kind of like Google Earth for GIS, or for GIS users. So it does the 3D kind of browsing capabilities that you're used to, plus you can incorporate your GIS layers. So I just want to give you a short little demonstration of some of the options here in the next segment. My questions revolve around earthquakes. I want to find out what the distribution of earthquakes are. So I'm going to click that little earthquake. Okay, I see some earthquakes there. Interesting. Global distribution of earthquakes. This is the G part of GIS, the geography part, the map. But there's an I part running behind the scenes. Okay, behind each of these layers on the left, on the left side there. If I right-click on each one of those layers, I can see the attribute table, which is the table of data behind the map. And I'm just going to drag it over to the screen here so you can see it. Okay, so this is a list of a database of 60,966 earthquakes. Now you can go to the USGS website and go and get the latitude longitudes of each earthquake and get a big paper map and put sticky notes or push pins on that. But it would take you a long time to get to 60,000. Not that more is necessarily better, but you've got a really powerful set of data here with a powerful toolkit on top of it. So my question is, one question is, oh, okay, well, where is the largest earthquake? That kind of comes to mind. Ooh, okay, so I'm going to, just like a regular spreadsheet, I can sort those columns. And I see that there's a magnitude 9 for December 26, 2004. Does that ring a bell in anybody's mind? What happened at the end of December in 2004? We were just talking about it. Steve just talked about it earlier. Okay. Now, let's say I'm 13 years old. I was in grade school in 2004. I don't remember what was going on then. So, okay, I'm going to zoom to it. And then I'm going to go back to my map. Okay, there it is. I see it right there. So, okay, well, I'm going to zoom to it. There's the earthquake right there in the middle of my screen. I don't know what these shapes are. Remember, I'm 13. I have no idea. Okay, we can label those countries. But let's go back to the world for the moment. Not all of these earthquakes are created equal, correct? Wouldn't I want to find out where the big ones are? Look at patterns of the large earthquakes versus the small earthquakes. Okay, I can do that. If I double-click on the earthquakes layer, I can go, and this is in the lesson. I just want to pique your interest first. This is all in the lesson. I'm going to map it on, please GIS, give me a map of earthquakes by magnitude. And, well, maybe I want these to be bigger symbols for the bigger earthquakes. Okay, so, yeah, something like that. Maybe I don't want it quite so large. Maybe I want it like this, 1 to 13 for the symbol size, and maybe I don't want them blue. Maybe I want it to be something like that. And maybe my big earthquakes, I want it to be red. Okay, see, I'm just picking and choosing, just like you would in a regular graphics program. Okay, maybe I want that one to be slightly smaller. Because I'm looking at the whole world, and I can see there's a lot of earthquakes there. Okay, so then I say okay, and it redraws, and while it's redrawing, it's going to give me a different look that I had before. Okay, now I'm going to see that, oh, I've got some bigger earthquakes here along this. Why is that? I've got looks like a plate boundary here, right, where these earthquakes are occurring. I don't have plates over here. I don't have a plates layer. Well, in that lesson, it has you add the plate boundaries, and then has you look at not all plate boundaries are created equal, right? There's subduction zones, there's spreading centers, there's transform boundaries, and there's also sort of diffuse kinds of plate boundaries. So that's what this lesson does. The last thing that we have as an option for this next segment is, you know what? I want to add data. And the data I want to add is related to this next question. This next question is, I read an article that the Haiti earthquakes of January 2010 were highly unusual. There's never been a historical earthquake over in Haiti before. I want to find out if that newspaper article is accurate. And I want to compare those earthquakes to the earthquakes that I'm looking at here. So I'm going to navigate back to the Mod 2 folder, and here is a data set that I downloaded from the USGS. Okay, so here is, let's take a look at this file, the I part of the GIS. This is January 14th through January 7th through January 14th, 2010. Okay, so I downloaded that from the USGS. Great. I want to map those earthquakes and see if they have anything to do with the historical pattern of earthquakes, which, as you can see, are largely off over here, right, over by the Dominican Republic. There's a couple over here on the west side of the island, but I want to find out then about those January 2010 earthquakes, and then I can say, yes, according to the data set that we have here, imperfect as it is, I'm confirming my newspaper article, or I'm saying the newspaper article was, they didn't know what they were talking about. In other words, the students are investigating. They're being the scientists. Okay, so that's one option we have for you. The second option that we have for you in this next segment is this sea level change activity. Okay, I'm in middle school, let's say. I've read that if the ice caps melt, the sea level will rise. Well, how does that affect different coastlines? Are they all affected equally or not? And are certain countries affected disproportionately than other countries? I want to investigate that. So I'm going to go ahead and open that project if I'm really interested in that. And so I'm going to go back here, and I'm going to open my file that is up on my computer, and we have this folder called GIS COGA ESRI, and that's over Mod 7, and okay, there's a Global 7, and okay, so idea here is I want to look at, please computer, let me see global sea level change. Okay, so, all right, 20,000 years ago. You mean climate change is not just a last 30 years? It's been happening for centuries? So it's nice to see, to incorporate this, because, the idea here is that climate has been changing ever since the Earth was formed. The question now, of course, is how much are humans impacting current climate trends? Okay, so let's go zooming into the Caribbean, where we were before. Oh, gosh. 20,000 years ago, Florida was a little bit fatter than it is now, wasn't it? Why? Because, again, if this is anchored in your lesson on retreat in advance of glaciation over the past 20,000 years ago, were the glaciers bigger or smaller than they are today? Bigger, so the sea level was... Why was the sea level lower? Awesome. Okay, so then I'm going to just click on the today. Then, what happens if it rises by 5 meters? It looks like some of these folks are going to be okay, but gosh, look at these islands. They must be low, right? If they're all underwater at 5 meters, can I right-click on the countries and label? Okay, yeah, okay, so the Bahamas, that's a problem.